When I created your syllabus before the start of school, I had failed to notice that 1-6 will not be a section that we will be covering. That's really just on a construction of lines, and we're going to develop enough as we go throughout the remainder of this course that's not going to be necessary to cover as a separate section unto itself. So we're going to skip straight ahead to 1.7, where we talk about the midpoint and distance in the coordinate plane. And we're going to introduce some things you've probably already seen in algebra, talking about the midpoint formula and the distance formula, and we'll build upon that again as we go throughout the course. So the first thing we're going to look at is a review. This should be more of an algebra review than necessarily a geometry review. For the 1 through 6, we're going to just label them as true or false. And the first one is that the points A and B are both at the origin. Well, remember, the origin is where the x and y axis intersect on the coordinate plane. And in this case, A is at the origin, but B, however, is above the origin. So this is a false statement. They are not both at the origin. Number 2, if AB is equal to BC, then B is the midpoint of AC. And we can look at the diagram that we're given there to the right, and you can clearly see that B is 3 units from A, and it's also 3 units from C. So this is a true statement. And also, just by the transitive property where we have AB is equal to BC, then that must mean that B is the midpoint. Number 3, the midpoint of AE is F. So if we look at AE, that's this segment down here across the bottom. F is 3 units to the left of A, but F is 5 units to the right of E. So that is not the midpoint. That is a false statement. Number 4, the Pythagorean theorem can be used for any triangle. That is the key word there is any. We know that to be false because the Pythagorean theorem only applies to right triangles. Number 5, the point C is at 6, 0. Remember, when we're looking at ordered pairs like this, it is an XY ordered pair. So that means first we move 6 units across the x-axis, 0 units vertically along the y-axis. So this point should actually be on the x-axis, whereas when we look at the diagram, it is on the y-axis. This ordered pair is actually 0, 6. So that is a false statement. Point E has a y-coordinate of -8. Point E is on the x-axis. Any point that's on the x-axis will always have a y-coordinate of 0, so this also is false. Well, today's not the day for me to make that mistake. So, and I did it 2 times in a row. 3 times. All right. So the vocabulary we're going to look at today is the midpoint. The midpoint of a segment is the point that divides the segment into 2 congruent segments. So that midpoint essentially bisects a segment, cuts it in 2 equal halves. And we're going to use that vocabulary to answer the questions for 7, 8, and 9. Number 7 says the midpoint of EF is G. And the coordinates for G are going to be at, let's see, how do we have this one labeled? So we have 1, 2, 3, 4, and here we have 1, 2, 3. The midpoint of EF is G, and G is at this location right here. So it's at an x-coordinate of 0, and it's halfway between 2 and 3, so we'll say it's 0 and 2.5. The midpoint of AB is blank, or the origin. So here's AB. So that is going to be 0, 0. If it is at the origin, its ordered pair is 0, 0. Then we have the midpoint of CD. Midpoint of CD is this horizontal line, and that's going to be the halfway point. So the x-coordinate is 1/2, or 0.5, and the y-coordinate is 0. Here's where we introduce the midpoint formula. And the midpoint formula is one of those you should probably already recall, especially if you look at it right now. You go, oh, okay, yeah, I know that one. But if you don't recall it, it's not that difficult to pick up. The midpoint formula is simply the sum of the x coordinates. We see that right here, divided by 2. That gives you the x coordinate of the midpoint. And then you add up the sum of the y coordinates and divide that by 2, and that gives you the y coordinate for that particular midpoint. So if we have the endpoints 5 and 9, and we want to find the coordinate of that midpoint. So now we're just talking about just a straight line. We're not talking about anything in the Cartesian plane. So if we have a line that goes from 5 to 9, okay, what's this midpoint right here? Well, what is 5 plus 9? 5 plus 9 is 14. 14 divided by 2 is 7. So the midpoint of 5, 9 is 7. For number 11, it's going to be negative 3 plus 5 divided by 2, which is going to be equal to 2 over 2, which is 1. For number 12, negative 10 and negative 3. So we have negative 10 plus negative 3 divided by 2, and that's going to give us negative 13 over 2, which is negative 6.5. Number 13, we have negative 8 plus negative 1 divided by 2 gives us negative 9 over 2, which is negative 4.5. On number 14, we're going to just complete this diagram and come up with the values here. So in order to generate the x-coordinate for the midpoint, which is right here that I circled in purple, we have to take the x-coordinate from the first point and the x-coordinate from the second point and add them together. So we get 1 plus 17. 1 plus 17 is 18. 18 divided by 2 is 9. We do the same thing for the y-coordinates. We take the y-coordinate of 2 plus the y-coordinate of 4. 2 plus 4 is 6. 6 divided by 2 is 3. So the midpoint of that line in the coordinate plane is going to be at 9, 3. We can use the midpoint of a given line to find one of the endpoints if we need to. And so right here it says that the midpoint of AB has coordinates 4, negative 9. Endpoint A has coordinates negative 3, negative 5. What are the coordinates of B? We know the endpoint of A is at negative 3, negative 5. So we're going to substitute that into the midpoint formula. And now we have an algebraic expression that we can actually work with. We also need to fill in here, though, the midpoint coordinates, which is 4, negative 9. So we separate this into our two equations. We're going to solve for the x variable and we're going to solve for the y variable to get that coordinate for the endpoint of B. For the x, we have x sub 1 plus negative 3 is equal to 4. That's the x value of the midpoint. We solve this algebraically. We multiply both sides by 2, and we have x plus negative 3 is equal to 8. Add 3 to both sides, and we get 11. We do the same thing for the y-coordinate. We have y sub 1 plus negative 5 over 2, and we know that's equal to negative 9. Multiply both sides by by positive 2 to get negative 18. Add 5 to both sides to get negative 13. And we have our endpoint for B. The coordinates are going to be 11 and negative 13. So we put it in that XY ordered pair. The distance formula is derived from the Pythagorean theorem. And we're going to apply that here. You can see from this diagram we have this leg. It corresponds to a squared. We have this leg is b squared, and then that gives us the hypotenuse, which is equal to the distance between the 2 points in the coordinate plane. So we can use the Pythagorean theorem to derive the distance formula, which is given up here as d is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. Using the diagrams above, we're going to draw a line from each triangle in column A to the corresponding side in column B. And we've already labeled that. Y sub 2 minus y sub 1 corresponds to side B. Change the pen here. X sub 2 minus x sub 1 corresponds to side A. And then the distance is the hypotenuse, which corresponds to the distance between the 2 points in the ordered pair. And that would correspond to C. So applying that using the distance formula, we have that SR has endpoints -2, 14, and R has endpoints 3, -1, or has coordinates 3, negative. What is SR to the nearest tenth? So we're going to have to complete this diagram that we're given. And we have let S -2, 14 be x sub 1 and y sub 1. Let R be x sub 2 and y sub 2, and then we're going to use our justification. So the first statement is the distance formula itself, which is x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Now we substitute in the values that we know. X sub 2 comes from point R, and so that's going to be 3. They've already provided us with x sub 1, which is -2. And y sub 2 also comes from R, is -1. When we simplify this, we get 5 squared plus 15 squared. And that's actually -15 squared. 5 squared is 25. -15 squared. Anytime you square a negative, it will be positive. Let's see, -15 squared is 225. And then when we add that together, we get the square root of 250. We will have to use a calculator to approximate that to the nearest tenth, because that's what the question asked for. So I go to Desmos. We are looking at the square root of 250. And we get 15.8. So the distance between R and S, or the length of SR, however you want to look at it, is going to be approximately 15.8 units. This next diagram, we're given a zipline course, and you're harnessed to the cable that travels through the treetops. You start at platform A and you zip to each of the other platforms. How far do you travel from platform D to platform E? So what we're looking at here, trying to find a color that'll show up good, is from D to E. That did not show up good at all. And the highlighter doesn't show up, but you guys can see where D to E is. So the first thing we want to do is apply the distance formula. 22 is already given to us, but that justification is distance formula. Then we're looking at segment DE is equal to 30 minus 20 quantity squared plus -15 minus 20 quantity squared. That's just substituting in the respective coordinates for each one of these points. You can see that E is at 30 and -15. That's where the x sub 2 and y sub 2 came from. And D is at 20 and 20. So that's where our x sub 1 and y sub 1 came from. So all we've done in this line here is just substitute in what we know. And then our final step is to simplify the process. We end up with the square root of 25, or 1,325. So we're simplifying. And the nearest tenth we travel about, and so that again we're going to have to call up the calculator. It's the square root of 1,325 So let's put that in, 36.4. And they already have the units on there for us. But remember, when we're dealing with if we're given specific units, whether it's feet, seconds, minutes, inches, whatever it might be, make sure your answer is in the context of those same units. Do we understand? How does the distance formula ensure that the distance between 2 points is always going to be positive? A radical, so that's just the square root symbol, with no sign in front of it, indicates a positive square root. So when we answer that question, the radical in the distance formula, remember the distance formula is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Because we're taking the square root of that value, it's always going to end up being positive. The other thing to notice as well is each one of these terms ends up being squared. So even if what's inside the parentheses comes out negative, when you square a negative, it all becomes positive. So that's why the distance formula always ends up generating a positive solution. Don't forget our quiz tomorrow. Our first exam will be later, actually be this Friday, I believe. We'll look over any questions you may have on Thursday before the test and get you guys ready to go. So I hope everybody's having a great day, and I will be talking to you again very, very soon.